Chapter 8 deals with aquatic biodiversity. Kind of gives you an overview of the different types of aquatic ecosystems that exist. So you may be a little bit less familiar with these than you are the terrestrial ecosystems, the biomes. It starts with a great case study about coral reefs, and there's a lot of information here that will be relevant in many future chapters and units. So definitely take the time to read this case study. All right, so 8.1 kind of gives you an overview of aquatic ecosystems. As we know, over 70% of the Earth's surface is covered in water, so it's important. When we talk about aquatic organisms, we can basically divide them up into three major categories: plankton, nekton, and benthos. Plankton are free-floating, so they don't swim, they just kind of float along. Phytoplankton are photosynthetic, incredibly important producers, and provide the vast majority of energy available in aquatic ecosystems. And then zooplankton are plankton that are consumers. Nekton are swimming consumers, so most fish that you think of are nekton. And then benthos are bottom dwellers, so lobsters, starfish, etc. Or sea stars, the technically correct term. There's some information on page 172 about turbidity. Pay attention to this. It will be important for our ecocolumns, right? As we start to watch what happens with the water in your ecocolumns. 8.2. Why are marine aquatic systems important? So this is focusing on the ocean. Figure 8.5 has some great ecological and economic services of marine ecosystems. These are really important to have at least a few of them in your back pocket for FRQs if that ever shows up. There are different zones, which we can see in figure 8.6, know them. So coastal zone, the euphotic zone, bathyal, and abyssal. There's descriptions in the textbook. So we have the importance of coastal zones and the wetlands. So basically we can divide coastal zones into estuaries, where the rivers meet the ocean, coastal or salt marshes, mangrove forests, as we can see in figure 8.10, and coral reefs. Coastal zones provide great biodiversity and a lot of ecological and economic services. Then we have the different types of shores and rocky shores, barrier beach, Plum Island, which maybe some of you have been to Plum Island. It's a really good example of a barrier island. It's been pretty heavily developed in parts of it, and there are a lot of houses that are at risk when we have large storms. Oftentimes you hear about houses kind of falling over due to erosion. So it can have economic consequences for the people who live there and also ecological consequences. 8.3 goes into how have human activities affected marine ecosystems. So figure 8.13 has a really good summary of how humans have impacted both marine ecosystems and then specifically coral reefs. About 50% of the world's population lives either along the coast or near the coast. So everyone is affecting these ecosystems in some way, but as the human population continues to grow, these effects will probably be more pronounced unless we do something. Right. Page 180 has a great description of cultural eutrophication. This is something we'll talk about multiple times. Basically what happens is there's an increase in nutrients, typically nitrogen and phosphorus, so things like nitrates. And when that happens, because those are often limiting factors, we get an increase in algae. Okay, which might be like an increase in algae. That's great, they're photosynthetic. But what happens is that decreases the amount of light that is available below the surface to the plants that might have roots on the bottom of the lake or of the ocean floor there. And then eventually what happens is all those algae die. The algae die, so we get an increase in aerobic bacteria that act as decomposers. Because they're aerobic, that lowers oxygen levels. So we get these dead zones where there's just not enough oxygen. So cultural eutrophication kind of happens on its own. Cultural eutrophication caused by humans So the activities in the entire drainage basin or the entire watershed can affect the health of a river and a bay. So the example they give with Chesapeake Bay is a great example of how that entire watershed or drainage basin that you can see in figure 814, all of the activities there play a role. Another place we see this happening is the Gulf of Mexico with the entire Mississippi River drainage basin. 8.4 gets into freshwater ecosystems. So again, figure 815, great examples of ecological services and economic services. You need to notice the difference between those, right? Ecological services benefit the organisms and kind of the natural processes that happen. Economic services, how can humans benefit from freshwater ecosystems? And then on the next page, we have the diagram showing the different zones, the littoral zone, limnetic zone, profundal zone, and benthic zone. The one that probably shows up the most often is benthic at the bottom. Then in turn, we just talked about cultural eutrophication, but there's information here about 3 different types of lakes that we can, or 3 different ways we can describe lakes based on the nutrients. Let's start with the middle, mesotrophic. Okay, so it has kind of a healthy amount of nutrients, so kind of ideal. Oligotrophic lakes have very few nutrients. These tend to be very, very clear, but there's not a lot of life living there. And then eutrophic are incredibly nutrient rich and probably covered in just giant mats of algae. Getting into rivers and how those change. So one thing to remember, as we've talked about before, the amount of dissolved oxygen decreases as temperature increases because warm water can hold less dissolved gas. So colder water will have higher amounts of dissolved oxygen. So if we look at figure 818, it shows kind of the natural flow of a river. So the source zone up in the mountains tends to be very cold because a lot of it is due to snow melt. And you're up in the mountains, so the temperatures are cooler anywhere. High amounts of oxygen, pretty low nutrients. It's very fast flowing, clear. And then the transition zone's kind of in between the other two. And then you get into the floodplain zone. This is where the water is warmer. There's less oxygen, more nutrients, very slow moving. It's going to meander a lot, as we can see there. And sediments and turbidity can also increase as we get into that floodplain zone. There's a really nice case study on page 184 about New Orleans and how the aquatic ecosystems, the freshwater ecosystems have been changed there. And then what's happened, you guys are probably too young to remember Hurricane Katrina, but you've heard of it, I hope. So the case study deals with natural protection that exists, kind of the pros and cons of dams, which we'll talk about again later this year, sediment and silt flow and how those can vary, and then the effects of rising sea levels and hurricanes. So check out that case study. All right, and then wetlands, so different from coastal wetlands, but kind of freshwater inland wetlands. Talk about marshes, swamps, floodplains, and then vernal pools. Vernal pools are seasonal ponds that are full of water in the spring, and then usually by the end of summer, early fall, they dry out. So they're really important breeding grounds for frogs and salamanders. And then 8.5, kind of briefly, how are we impacting freshwater ecosystems? Excuse me. So dams and canals, we change the flow, levees, dikes, pollution, both from cities and agriculture. We tend to think of pollution as a city thing, but agriculture is definitely a culprit when it comes to water pollution. And then drainage and filling of wetlands. So there are laws to prevent these things from happening now, but a lot of it, if you think about Boston was almost all wetlands, and then it was filled in, hundreds of years ago, and we have forever changed that ecosystem. So that is chapter 8 in a nutshell.